Let's take a look at some different compounds and how to write Lewis dot structures for those compounds that are exceptions to the octet rule. In these examples, we have the first molecule that has an unpaired number of electrons. This one that is happy to have less than 8 electrons around it. And then this one has more than 8 electrons around the central atom. So let's take a look and see how we can write Lewis dot structures for each one of these. First of all, let's tabulate how many electrons I have. I have 1 nitrogen, which gives me 5 electrons, and I have 1 oxygen, which gives me 6 electrons, for a total of 11 electrons. Notice that it's unpaired already. Now let's bond these two elements together. Obviously, there's going to be more than one single bond because I don't have enough electrons. So I know that for oxygen likes to have, once again, either a double bond with 2 lone pairs or 2 single bonds with 2 lone pairs. In this case, I can't single bond it to 2 different atoms, so it will have a double bond with 2 lone pairs, and oxygen will have 8 electrons around it, and it's happy. Now let's look at nitrogen. It has 2, 4. It needs 4 more. However, I ran out of electrons. I only have 3 more to give it. So it will have a lone pair and then a single electron that is not paired. I have 2, 4, 6, 8, 10 plus that 1, 11. So I've used up my 11. But I have 1 unpaired electron. This is why this molecule, the old name for it is nitric oxide, but the correct way to name it is nitrogen monoxide. It is very reactive because it has that unpaired electron, and it's looking to pair it up so that nitrogen will have a full octet. But know that this is the correct formula for this particular molecule. Let's look at the one that can live with less than 8 electrons. I have boron and I have 3 hydrogens, so 3 hydrogens, each one giving me 1 electron. So 3 electrons from the 3 hydrogens. 1 boron will give me 3 electrons as well, for a total of 6 electrons. That's all I've got. Now, once again, hydrogens are terminal. They bond only once with 1 atom. And I have what I have the least of, so I have 1 boron to 3 hydrogens. So this is going to be my central atom. This is going to be the one to which all the hydrogens are bonded. Okay, now I look at all hydrogens. They're happy because they have their 2 electrons. And I have 2, 4, 6. I have used all of my electrons that are available. Therefore, the boron here does not need to have 8 electrons around it. It's happy with 6, and this is the correct Lewis dot structure for this molecule. Let's look at the last example where phosphorus can accommodate more than 8 electrons. Okay, so I have from each chlorine, so I have 5 chlorines, and each one of them contributes 7 electrons, so I have 35 electrons from all the fluorines. I have 1 phosphorus, and the phosphorus will give me 5 electrons, for a total of 40 electrons altogether. And now I'm going to kind of erase this a little bit so I have some room here. Now that I have the total number of electrons, I can write this out. Remember that what you have the least of will typically be your central atom, and I have 1 phosphorus and 5 chlorines. So my phosphorus will be the central atom, and all the chlorines will be bonded to this phosphorus. Okay, now each chlorine, remember from the halogens, they all have 1 single bond and then 3 lone pairs. So I have to go in here and put 3 lone pairs on each of my chlorines. And that gives them a full octet, which is what they want. Okay. Now let's count the total number of electrons. 2, 4, 6, 8. So I have 8 for 1 chlorine, But I have 5 chlorines. That means I have used up all my 40. So 8 times 5 is 40. My chlorines are all happy, 2, 4, 6, 8. And because they have the full octet. But my phosphorus, let's count, 2, 4, 6, 8, 12. It can have 12 electrons around, so 4 more than the octet. But phosphorus and sulfur are 2 of the exceptions that they can accommodate more than 8 electrons around. 2 that are the ones that we're going to talk the most, but there are others as well. These are some of the exceptions to the octet rule. And then in the next slide, I'm going to erase this and we'll work on some more Lewis-Dell structures.